Well, you know what? One of the main reasons why I came over here is I heard you were working on a 2000 to 2005 Kia Optima.
Yeah.
And the rumor on the street is that, like the DSMs having the Sirius engine platform, this actually is using the Sirius II engine, which is the same one found in a Lancer Evo. Is that right?
Yeah, there's a lot of very close similarities. The cylinder head is actually, from what I can tell, the same cylinder head as an Evo.
Okay.
There might be different camshaft grinds. I got it for $48.
Those are
with
the
the core.
same rollers as in the 2G.
Yeah, these are like the revised
lifters.
3G lifters with the big, what is it, a 4mm opening? I forget what,
It
3
looks
millimeter.
like the same oil pressure galley thing.
Yeah, the regulator for the head. Essentially, it looks like a 1G and a 2G head, except for over here, that's a little different. These are probably the same exact gaskets. You do have a piece on the end of the camshaft that bolts up. It's like a pickup or something for the cam angle sensor, which is a little different. It's probably just like the same thing on the Evo. Retainers are definitely smaller on this one. I noticed that. These are smaller retainers than regular DSM stuff, which means the valve springs are probably a touch smaller.
No, this is the intake side.
Yeah.
So the injector bores are in the intake manifold instead. Like
yeah.
Wow.
Big valves, really. I mean,
yeah.
You know, considering it's a bigger bore and you've still got shrouded valves, what I mean by shrouded is, see, part of the valve actually goes into this area right here. That's, I think it's called a quench area.
Mm-hmm.
If you have too much compression, never use a bigger head gasket to compensate, because what happens is you create a very large gap between this area and the deck of the block, and that type of quench area being big like that actually promotes detonation. So you lower in the compression a half a point with a bigger head gasket can actually give you more detonation.
Yeah. So
tune around the compression. Don't try to delete the compression. Compression is a good thing. It's working like a charm in mine. Even with the 1.6 head, the valves are really shrouded. Half the intake, or a quarter of the intake valve, is shrouded by this piece right here.
Huh. And
messes up the airflow a little bit.
Where's our teardrop? Looks like that's where the oil pickup is.
Yep, it's your oil feed from the block going up to and through there.
Interesting.
Yeah. So that's why you don't want to mill these heads down too far, because then you take out all that metal right there, you'll have not much oil getting to the head.
Yep.
Not a good thing.
It's pretty awesome. And what do you think the similarity is between this and the Evo 8? Do you think it's the exact same cast?
I think people have actually used them and they said the only thing they have is a missing water connection for the turbocharger. But see, like I said, here's the thing. This hose that comes off of here, cut it and put a brass T in it. I had to do it on that car, and I think it was a $2 part. So you can run a rubber hose to where the original connection was on the turbo, and you know, for just a few bucks, you can use this on your Evo, and you'll have the H and the Kia.
That's about the only difference right there. I love the Hyundai designation. It lets you know where this South Korean motor company stole their engineering designs from.
Yes, I'm sure.
Oh, look at that.
Yeah, it's
that's the same
metal plug.
same metal one that I got on my DSM, and I polished mine. Remember, I polished the seal.
Oh
no, that's just a little ice cream.
Yeah.
Anyway. Oh wait, no, that's not how it goes.
This engine is going to be backwards. The timing side's going to be over there.
Well, I know a lot of people are going to say the Evo engine isn't backwards, that it's normal, but I'm an old school guy and I think it's backwards.
When we think of an Evo engine, we still think of the cam sprockets being over here.
Yeah.
Because that's Evo 133, our true 4G63.
Yep. Then they went, what, the 7-bolt? There's the Evo 3 is a 7-bolt though, isn't it?
It may be. Yeah, Evo 1 and 2 is the old school.
That's right. So then the engine got flipped around with the Evo 8.
Yeah.
And
they saved 6 pounds, by the way, in doing that, because they could get rid of the countershaft in the transmission, which corrects the rotation. So yeah, they saved 6 pounds by flipping it around.
Unless you're in Australia, right? Because everything spins backwards on that side of the equator. Then you need your balance shaft.
That is true. You just go there and flush the toilet and watch it.
That's right. Coriolis force, right?
So yeah, I picked this up about About a month ago.
Get a good deal on it?
Awesome deal.
Yeah.
I got it for $500 delivered.
Yep.
I went to look at the car. I saw the ad online. It had no pictures, but I said, hey, a 04 Optima with a blown engine is asking $700. I knew a few things about these cars. I'd seen a lot of them out in the junkyards and stuff, and I knew immediately that when he said he needed an engine that it was a timing belt failure victim, because apparently these cars have timing belts, and a lot of people don't realize that. So you know you have to change your timing belt every 60,000 miles.
Yep.
When you drive a car that has a timing belt with the factory belt, you drive it 120,000 miles, and damn it, you know what? The timing belt just broke. It must be the car's fault. No, it couldn't be the fact that you went
Oh, these
double.
things are such pieces of junk.
Yeah, they're incredible pieces of shit.
I'm curious to see this block. Is that possible?
Yeah, I got one right here. So yeah, you're gonna notice this is a lot like a 2G block. So you might actually say this would be closer to a 4G64 and a
Look,
Galant.
it's the same knock sensor.
It is.
Wow.
99 to 05 Galants.
Mm-hmm.
The Sirius II style engine where the time and stuff's on the passenger side of the car.
Oil squirters right there.
In the main gallery.
In the main gallery on each one of. That's a good idea to put both of those off of that.
Nothing that's going to break off and fall down in the oil pan, and nothing that's going to you have to literally take out of the block to just even hone it.
Mm-hmm.
The oil jets get caught on the stone. It's not pretty.
No.
I just happen to have a set of 7-bolt bearings laying around for 93 or 92 and a half to 99 Eclipse 4G63. These bearings also fit in the 93 to 99 4G64. All of the bearings from the mains to the rods will work on this engine. The only one I found that I had an issue with is the center main, which has on the older stuff.
That's the thrust bearing, isn't it?
The thrust bearing. On the older stuff, the thrust bearing and the main bearing in that center is all one-piece bearing. Now this engine uses the 3-piece design where you have the 2 washers and then the 2 half rounds. I couldn't use the 1-piece in here, but I was able to take these 2 thrust washers that were in the engine in this car, and I've got the set that came out of this block in the junkyard, and I'm going to dry fit everything and measure the end play with either set and see which one is closer to what end play I need. When I figure out which one that is, I'm going to use that. And 2 of the half rounds that came with this engine that actually cleaned up pretty damn good. There's no real wear on them. And then the rest of the bearings, the other 4 mains and the rod bearings will all work. The 4G64 and this engine, like everything from the the compressor bracket, the starter, the cylinder head gasket, it's all the same. I did notice one difference between this one and the Galant. The oil pump actually puts the timing belt sprocket on the upper side of the balance shaft. Typically on the DSM and the Galant 4G64s.
It's on the lower side.
Yeah, this balance shaft goes through here,
yeah,
but the oil pump drive sprocket is below it.
Below it.
This one they put it on top. I'm not sure why they did it. It may be because it's a dual overhead cam, and to make the same belt on the single cam work, they moved the sprocket up to take up the difference of the other cam. I don't know if that's what they did. And I also don't even know that this block bolt pattern on the front is exactly the same as a 4G64. The gaskets online look different. I've never had the 2 of those side by side, but I can say that the head gasket on this engine and the Galant 4G64 from about a 93 all the way up to 2000 before they did something different is the same head gasket. And incidentally, the intake manifold gasket for the DOHC Kia head is the same intake manifold gasket for a 2G
7-bolt setup.
Right, so if you wanted to turn your 2G engine long ways and make it rear-wheel drive, you use the intake manifold off the Kia Optima because it's a backwards engine, and then you'd have the throttle body looking out the front.
Huh, yeah.
Just something you throw out
the plenum
there.
volume would still be the same, be 1.5 times the engine displacement, right?
Yeah, I've actually got, it may be in the trunk. Yeah. No, it's not. This is the radiator and condenser assembly out of this car here. So yeah, this is the new clutch kit that came with it. When I was going over the car, I knew I bought it home and everything. Oh, cool, new clutch kit. Hey, what kind of pressure plate is that? Never seen that before.
It's weird, it's all backwards.
Yeah, this is a pull type clutch assembly. Now when you open one of these, I don't want you to go, oh cool, a snap-in throw-out bearing. Let me go ahead and snap that in. Don't do that. Because then you won't get it back out. And when this thing's attached to the pressure plate, you can't get the transmission on there because the clutch fork has to roll into it, and what you do is you actually take the throw-out bearing, you slide it on the snout on the input shaft, put the clutch fork in there, put this on the flywheel, and then slide the transmission on, and then with the slave cylinder disconnected, you take the release lever, and since it's a pull type, you want to push it. When you push the lever the other way without the slave cylinder attached, it snaps it into the pressure plate. This snapping action actually just needs to happen after the transmission is installed. Don't do it before.
How many splines are on that clutch disc? Is that the same one as for a DSM transmission?
I got a DSM transmission. Let's go find out.
It looks smaller. Let's see.
Hey, look at that unsprung hub.
Look at that.
So, yeah, I just happen to have a 1G front-wheel drive NA transmission. I don't know that that's the same spline as the turbo, though. I thought, no, that's clearly not.
Yeah, the turbo one's way bigger, isn't it?
This ain't even. Oh wait, look at that.
Look at that. Slides right on.
I don't know what good that is, but there are some similarities here. This transmission is actually the same one you'd find in a like a Dodge Stealth. Some of the Dodge Stealths had 4G6. No, what is it? Dodge Avenger.
Yep.
Yeah, or a Sebring. Some of them had
Avenger.
4G64s. Same clutch design, pull type. The 3G Eclipses with the 4G64 would have a pull type clutch. Sonatas, all the G4C, what is it? G4J? I can't remember. The
G4CS.
Something like that.
The
Hyundai's
G4CS is a 2.4 liter.
Yeah.
Yeah.
Hyundai's have different engine codes than the DSM stuff. They're just the same thing. There's just so many minor differences. And once you know all of them, you know, you can find out what will work and what wouldn't work. Anyway.
Intake manifold's probably in that bin, isn't it?
Yeah, it's in there. Let's pull this out.
Do I see a plastic fuel rail? That has a plastic fuel rail.
Yes, it does. The regulator is built into the end with a clip spring that holds it in. And the fuel supply and return lines go on the same end of the rail, which is pretty cool. These are the newer style injectors that are on a lot of cars now. The little mini Bosch.
Why do the ports look a little bit smaller than a 2G?
It may be.
Maybe it's not that. Maybe it's just the machining tolerance here.
I don't know. This definitely needs clean. I see sand and stuff in here.
Nice.
I'm going to clean that out
Don't
real
worry,
good.
I've got mud dauber's nest inside the Colt intake manifold right now.
So
that's a 2G plenum right there. That'll bolt right up. Hey, look at that. The EGR valve is even...
It's just like a 1G.
Wait a minute.
That's a 1G.
Wait a minute now. That's on the opposite side of the block. You would have to block that off.
No, it's not.
You sure about that?
Oh, wait, yeah, you're right. Okay, yeah, so...
You'd have to block it off.
That would not bolt up. I always thought it would. I guess when you're looking at the gasket, if you flip the gasket over, it looks like it's right, but it's not.
Well, I mean, you can block it off.
Yeah, and you're going to block, you're not even going to use it anyway.
Right,
so.
you just block it off at the head and block it off on that.
Yeah.
And you can flip that around backwards and be straight.
You could still use this on DSM stuff to go rear drive, which would be a budget way to do it.
Yeah.
But most guys doing rear drive are going to use custom intakes anyway because they're all about high RPM. You know, because you got these long runners.
Well, I'll tell you now, that is the exact same bolt flange pattern of the 2G. So the way this flange works, the hey, look at that.
Crank angle sensor. It's the same.
Wait a minute, the same as the 2G? Are you going to use that?
Yeah.
Darn.
Yeah, I got to use that. I got a new plug for it. That's all I got.
Because I've got a secret coming for the Colt build here shortly.
Okay. You doing a crank trigger kit or something?
No spoilers.
Oh, okay. Look at the end of the valve cover on this side right here, where that high ridge is that goes down. It looks very much like an Evo. That's what gave me away when I was out in the junkyard. If I could just mentally block out the goofy letters that stick out, with that stupid looking letter style, and that shitty oil cap, it just looks like an Evo valve covers.
Right on. How about the crankshaft?
1G 6-bolt crankshaft here.
Put it on carpet.
Oh, it's got cobwebs. There's tiny little bit of scratching going on here. It'll polish out. Rule of thumb for machining, bearing surfaces and stuff like that. Something that's not absolutely critical like this. A tiny low spot, scratch. Nothing to worry about. A big high spot, like if you had a spun bearing and a big wad of metal came off the bearing and got embedded into the surface of the journal, that creates a high spot where it's like a slag of weld on there. That's a problem. A little light scratching like this, I'll probably just take this by the machine shop and have them touch it on the polisher real quick just to shine it. I may even do it by hand. You're talking like 600 grit 1-inch sandpaper. You can tell 6-bolt stuff's always got the wider bearings, physically wider. 100mm crankshaft, 88mm crankshaft on the stroke. So basically you could take the Optima crank and put it in your 2G if you wanted to do a stroker.
2.4 liter.
Yeah. 2.3 smaller bore.
How about the deck height on that Optima block?
6mm taller because its stroke is 12mm greater.
Okay.
And it uses the same compression height. Well, here, I got them right here. I can show you. I know a lot of these numbers by memory because I've done a lot of them, but your rod length on your standard 1G is 5.906 center to center. Rod journal is like 1.771, something to that effect. They're the same. This is a lightweight 2.4 rod out of the Optima, 5.906. Same bearing width as a 2G, 7-bolt, 4G, 6.4, Sirius II. 1.37 on the pin height. I've measured that in metric. I forget what it was. I think it was 35 or 36mm. I just didn't have a standard measuring tool for that. But ring sizes are the same as a 2.4 out of a 93 and up Galant. A lot of Dodge stuff. Anything with a 4G 6.4 or a Sirius II. So the thing is, this Optima has got a lot of parts that Galant guys can use. It's got a lot of parts that Eclipse guys can use. It's got a lot of parts that even Evo guys could use. And a lot of people don't know this because it's just thought of as a cheap, shitty.
It's a Kia Optima. You don't expect that to have a 4G 6.3 because Kia was not part of the DSM partnership.
Never was.
But one of the companies that was, Hyundai, is centered out of South Korea, and so is Kia.
And Hyundai's still using Mitsubishi stuff. I did not know this in 2004. I thought Hyundai had ditched the whole Mitsubishi copy lineup back in '97 when the Sonata went away from the 4G engine and went to the Beta engines. Beta engines are the 2.0 and the 1.8s out of like the Tiburon and the early Sonatas. Those are actually Hyundai engines through and through. They may still use like a Mitsubishi starter and a water pump and stuff like that, but the Sirius II engine is still a Mitsubishi construction. You can look at telltale signs of good quality stuff, like on your connecting rod where this fat line that runs through the center right there, that's called a parting line. And if you notice on some rods, it'll just be a thin pencil, like a pencil thin line going across. If you see that line, that's a cast steel rod. The fat line like this is forged steel. So that's how you can tell that's forged. You just have to look at that line. That's same pin, 22mm wrist pin. There's no taper, it just has a center ridge in the middle for structural support. Typical DSM pistons, the little steel inserts in there for strength. The roof is a little thinner on this piston than the early stuff. I think the stock DSM stuff, even on the non-turbo applications, the roof of the piston is almost like 3/8 of an inch, closer to 1/2 of an inch thick. It's a heavy piston, but it's just absolutely bulletproof. The rod is lots lighter than the early DSM stuff. The bore is the same, it's 86.5mm. Now I don't know about the compression and all. I think these pistons are going to have a bigger dish than the Galants. Well, the Galants have more of a flat top piston, which would lead me to think that if you put the DOHC head on the Galant, you'd have a higher compression engine. Should be the case. And this is the first one of these I've ever taken apart, so I've noticed a lot of similarities between that and the DSM stuff. Okay. These are 2 thrust washers. If you're looking at the center main, they're going to be on the top side, on the upper block side, not the lower main girdle. These Sirius IIs have a one-piece main girdle design. It's a lot like a 2G, I believe. The main cap is all one piece. It's all girdled together. If you have bearings that look like this, one with a groove and one without, the groove goes on the top.
Goes on the cap, not inside the block.
The groove needs to be on the top. The load bearing side, which is always the lower main on a main bearing, needs to be a full surface bearing.
That's because when the boom happens, it needs to have as much material.
A rod bearing takes pressure in both directions through acceleration, deceleration, closed throttle, open throttle. Mains always take pressure on the bottom side. So now here's your 1G stuff all the way up to, I don't know if your 2G was like that. Probably not. I think in 2000 when they flipped the engines around, that's when they changed from this design to that design. So it's just worth noting that even though these are totally different, to show you how similar the cranks are, I was able to use this entire bearing package for that Sirius II engine, I've dry fitted everything and checked it. It works, except this bearing. Even though, however, you lay it in this crankshaft, get a feeler gauge out. Got about
Light deficient.
this is a dry fit now. Even with a dry fit, I had 4/1000ths. This is how you, one way you can measure in play if you're using this style of bearing would be to take this bearing, stick it in there. You know it slides forward and backward.
Feeler gauge it.
Feeler gauge it. 3 to 4/1000ths is pretty good. The service spec is from 2/1000ths to 10/1000ths. 10 is a little high, 4 is good. It's a 5-speed car. You don't want all that clutch engagement, disengagement, having a lot of room for the crank to build up momentum and slam into that.
Mm-hmm. But you'd have 2/1000th on either side of it if it's centered on the bore.
Right.
So
you're good to go. And then of course the oil fills up some of that cushion with a little bit of pressure.
Mm-hmm.
So just to show that this crank would in fact fit in a 4G64 or even a 2G7 bolt, it would work. And you know, you can get a crank out of the junkyard down here for, I think it's $20.
Yay!
It's in good shape.
2.4 liter crank
Yeah.
for 2Gs. Yay!
There you go. So that shows that that does work, even though it's a totally different style of bearing. The difference that they made was in the blocks. Just for the sake of argument, if you were to call Kia and ask for the price on a long block, just for the long block assembly is, I believe, $4,500.
Whoa!
So if I'm at $81 on the build right now, and the only thing I have left to do is buy rings and gaskets and seals, hey, I think I've done pretty good.
Yeah, no question. Well, Jamie, man, thank you so much. I appreciate your time and telling me all about this kind of stuff. I wanted to take a look at this, and you made my trip worthwhile. I learned something today.
All right. I'm good. I've stocked up. All right, thank you.
Clearly, we're not busy.
No, not at all. Anyway,
I'm only holding a camera that's as big as a bazooka, filming somebody talk.
who doesn't buy their meat out of a van?
Why
You know
not?
what I mean?
Yep. The meat van just came by.